In a traditional office building, the ratio of users to workspaces is strictly 1-to-1. An employee arrives, sits at their designated desk, remaining the sole occupant of that square footage for the workday. Co-working spaces abandon this model. They operate on high user density and zero territorial ownership. This shift creates the vector multiplier effect. Rapid turnover transforms static furniture into active transmission nodes, creating an overlapping web. Isolating a single hot desk reveals the scale. Over 5 days, one workstation hosts 20+ individuals, creating a continuous chain of physical interaction. Standard commercial cleaning services are built for the traditional model, sending crews in after hours to empty bins and vacuum floors. When traditional low turnover assumptions are applied here, janitorial systems fail to address the actual volume of daily interactions. The vulnerability concentrates at shared interfaces. Every hot desk keyboard, communal coffee machine, and phone booth door handle acts as a highly efficient distribution point for bacteria and viruses. To neutralize that distribution, operators have to deploy a hygiene architecture engineered specifically for continuous, nonlinear cross-contamination. Without a specialized high-frequency hygiene system, the very features that make a co-working space collaborative also turn it into a biological liability. The first step in that architecture is abandoning the idea of a uniform floor plan and establishing a zonal risk matrix. A 3D analytical model maps vulnerabilities, starting cool blue. It identifies hot desks as rapid reset zones where biological loads spike. Meeting rooms act as enclosed amplifiers, their risk signature intensifying over hours. Finally, communal kitchens and washrooms consistently register as maximum biological load centers. Meanwhile, the reception area functions as a strict traffic funnel, processing 100% of the daily population through its footprint. By categorizing the space into these distinct operational zones, facility managers can dictate exactly how often a specific area needs cleaning. A high-frequency zone, like a hot desk, requires attention multiple times a day, whereas a lower-frequency zone, like the soft furnishings in a lounge, requires scheduled deep extraction monthly. As occupancy fluctuates, managers can use active traffic analytics to adjust this risk matrix in real time. Mapping this unequal risk distribution is the mandatory starting point. You cannot deploy operational resources efficiently until you know exactly where the biological load is concentrating. Once the spatial analysis dictates where to clean, the focus shifts to the micro-level execution on those high-touch surfaces. There is a strict operational difference between wiping a table for visual aesthetics and executing true chemical disinfection. Disinfection relies on chemical contact time. A liquid chemical requires a specific, uninterrupted duration on a surface to physically break down bacterial cell walls. Protocol matrices strictly dictate these dwell times. The exact number of minutes required depends entirely on the specific pathogen being targeted and the chemical agent deployed. The application protocols also diverge based on material. Porous surfaces like fabric chairs absorb agents differently than non-porous surfaces like glass tables, requiring different compounds. Because shared device interfaces and door handles are touched constantly, applying these precise chemical protocols once a night is inadequate. They require multiple interventions throughout the day. This necessitates a systemic process called a session-based reset, where cleaning teams execute targeted chemical applications multiple times during peak operational hours. To ensure long-term efficacy, facility managers rotate the specific chemicals used, which prevents microbial populations from developing resistance. Every chemical application and rotation must be rigorously logged, creating a documentation trail that proves compliance for health and safety audits. Surface hygiene is an exact chemical equation, demanding strict temporal compliance. Treating it as a superficial aesthetic chore guarantees failure. Treating surfaces handles direct contact, but a complete hygiene system must also manage invisible environmental factors, primarily air quality. When high-density spaces are enclosed, like soundproof phone booths, stagnant air allows airborne pathogen loads to multiply. Managing this requires strategic HVAC circulation. This cross-section illustrates how mechanical systems must continuously draw in fresh air while actively extracting stagnant, particle-heavy air through dedicated vents. Beyond pathogen control, this optimal ventilation delivers secondary operational benefits, providing odor control and sustaining cognitive comfort for members. However, even the best mechanical and chemical systems eventually hit a mathematical ceiling without the active cooperation of the members themselves. Operators manage this through distributed responsibility, integrating the users directly into the facility's daily hygiene network. The most effective tactic is deploying frictionless sanitization stations, built into the architectural millwork at key transition points, so their use becomes automatic. Facility managers pair these stations with strategic hygiene signage. The wording is carefully calibrated to actively modify user behavior without appearing punitive. When members interact with these visible systems, it provides immediate psychological reassurance that the environment is actively managed. Total facility defense relies on this triad: exact surface chemical protocols, active environmental air controls, and engineered user behavior. The complexity of managing a high-density vector network places it outside the capabilities of standard janitorial crews. Executing structured protocol matrices during active operational hours requires highly trained staff who understand contact times and chemical rotation. These professionals navigate a delicate balance. As seen here, they neutralize biological risk efficiently without disrupting the collaborative atmosphere the members pay for. When executed correctly, the integrated system operates seamlessly, with targeted risk zones, exact chemical contact timing, active environmental air control, and engineered behavioral design, all working in tandem. This systematic approach creates a measurably lower risk profile. Watching the heat map, we see how continuous intervention consistently suppresses the high load signatures across all floors. Maintaining this rigorous standard ties directly to the bottom line, driving higher member retention rates and securing lease renewals. Furthermore, the extensive documentation required to prove hygiene compliance serves as a legal shield, protecting the operating company from liability. Members sign leases for co-working spaces because they want a securely managed, frictionless environment, rather than merely leasing physical desk space. In the modern co-working industry, an optimized, system-driven hygiene architecture is the operational requirement that makes the shared model viable.